Hello, this is section 2.3, number 17. The directions say, evaluate the limit if it exists. For question number 17, we are given the task of evaluating the limit as h approaches 0 of -5 plus h, that quantity squared, minus 25, all divided by h. Okay, so often there are many ways that we can handle these types of problems. But in specific terms of this case, what I usually like to do is simplify the top as much as possible, see if anything cancels with the bottom, and then evaluate the limit. But notice, if I evaluated the limit directly now, I would plug in h equals 0 here and here, and I would get -5 squared minus 25. Well, that's 0. And then I would get h is 0 here. So the temptation can be to write, well, this is 0 over 0. Okay? And once again, that would be because I put h there for 0, and I get 25 minus 25, which is 0, and I plug it in and I get 0. Okay? And then often what happens is people then go, oh, well, 0 over 0 is undefined. And so they leave that as their answer. Let me tell you a little bit of a secret. If you are writing this ever on a test or quiz as undefined, and you've written 0 over 0 equals undefined, I can guarantee you that you have not answered the question correctly. This limit does exist. It is not undefined. So this is a common mistake that people make. And I want to make sure that you don't make that mistake. Okay, so let's work out how to actually and correctly solve this problem. The first thing that I'm going to do is simplify or expand this top. So the limit as h approaches 0 of. So this would be -5 times -5 is positive 25 minus twice the cross product, so 10h plus h squared. Then minus 25. All divided by h. Okay. Now, the next thing I want to point out is it is often the mistake that people will forget to write the limits. So I wrote limit here, and I wrote limit there. So people sometimes will forget and they'll not write that limit part. Well, that's wrong. And the reason it's wrong is, once again, without the limit, this function may or may not actually equal this function. Without the limit. Remember, limits are a number, and that number actually exists. And so without the limit, you have the situation where the two things are not the same. Let me give you an example. This is a simple example, but let me tell you. If I had the example of x squared over x, if I simplified that, I would just say, well, that's the same thing as x squared over x simplifies to just x. And you would be right. There's nothing wrong with that. The problem is, if I said f of x is equal to x squared over x, and g of x is equal to x, and then I ask you the question, does f of x equal g of x? Are those two things the same? Most people, if they're not being careful, would make the mistake and say that yes, in fact, they are the same. F of x and g of x are the same. Why? Well, because this x squared divided by x simplified to x. But the problem is that is incorrect. They are not the same. Why? Well, f evaluated at 0 is actually undefined. Why? Well, because I'd have 0 squared divided by 0, which is undefined. However, g of 0 is equal to just 0. So f of x and g of x are not the same thing. And so we have to be careful when we're using limits that we apply the limit function or the limit command to our functions. Because now with a limit and a limit, when I begin simplifying things, I don't have to worry about getting into the situation where I made the mistake that could be made there. So the reason we have to write that is because, in fact, the limit as x approaches 0 of f of x is, in fact, the same as the limit as x approaches 0 of g of x. Because I have the limit and I have the limit, these two things are the same, even though these two things are not the same. This doesn't have a limit, this does. So that's why it's extremely important when we're working out limit problems that we make sure we write the limit in each and every step. Okay, let me erase this part. Okay, so now I'm going to have the limit as h approaches 0. And this positive 25 and that negative 25 will cancel each other out. And I'll be left with negative 10h plus h squared, all divided by h. Okay, then what I'm going to do is take the limit as h approaches 0, and I'm going to factor out an h out of the first two terms of the top. So I'm going to have h times negative 10 plus h, all divided by h. Then this h and that h will simplify to become 1, and I'll have the limit as h approaches 0 of negative 10 plus h. And this is a polynomial, so I can apply the limit directly. So I'll have negative 10 plus 0, which is just equal to negative 10.